Alright, so this is you're leaving some math class, you're going to geometry video. At some point you've seen all of these type of problems before, and a lot of this is just review of the algebra concepts you already know. So that's what we're doing. We're looking over this stuff so you can practice it over the summer. First thing is we have solving equations. Well, in order to solve an equation, the first thing I would always do is try to simplify both sides of the equation first. So the first thing I can do here is I can distribute that 5. When I distribute the 5, this left side becomes 2b plus 15b minus 20, and I still have a negative 156 on the right side. Well, that negative 156 can't be simplified anymore, but over here on the left side I can continue to combine like terms. I have 17b minus 20 equals a negative 156. I can add 20 to both sides to get 17b equals a negative 136, and then I can divide both sides by 17, and when I divide that by 17 I get a negative 8. So b comes out to be negative 8. Moving over here we have proportion. Well, in order to solve proportions we can use cross multiplication. I can divide the denominator of one fraction by the numerator of the other. 5 times 4 gives me 20. And I have 7 times k plus 8. Well, I can now multiply those together by distributing that 7. I get 20 equals 7k plus 8. Sorry, 7k plus 56. I can now subtract 56 from both sides. 20 minus 56 gives me a negative 36. And then I can divide both sides by 7. So k comes out to equal a negative 36 over 7. We can't reduce that fraction, so we just leave it the way it is. Moving on, we have this equation where we don't have any numbers. We don't have a clear variable we're trying to solve for, but we're told to solve it for x. So we want to get x completely by itself, and we're going to have a bunch of letters in the problem, but we just let it be. So we could solve this very similar to a proportion if we wanted to. I can see that I can write this other side as Pn over 1. We can write anything as being over 1. And once again, I could use my cross multiplication. I could do x times Pn and 1 times n, or 1 times m. 1 times m is m, and x times Pn is xPn. Everything's just being multiplied together. To get x completely by itself, I divide by what's multiplying times x. So I'm going to divide both sides by Pn. The Pn cancels out over here on the right, and I now have x completely by itself. And on the other side, I have m over Pn. So x has been solved for. All right, you've seen linear equations before. We obviously have the different forms. We've got our standard form, slope-intercept form, which is our go-to. We've got point-slope form. We might need to use our slope formula, and we also have facts about parallel lines and perpendicular lines. Parallel lines are going to have the exact same slope. Perpendicular lines, the slopes are going to be opposite reciprocals. So if we're trying to create the equation of a line, we always want it to be in slope-intercept form. So if we're looking at this and we are given the slope and we're given the intercept, well, all we have to do is plug it in. We know y equals mx plus b, where m is the slope and b is the y-intercept. And we're done. If we're given the slope and the y-intercept, all we have to do is plug it in. Over here, we've got the equation of a line in standard form. Well, I mean, this is the equation of the line, but it's not in slope-intercept. That's what we want. We need to solve it for y to be in slope-intercept form. So to do this, first we need the term with y by itself. So we're going to subtract 4x from both sides. Now we have 7y equals a negative 4x plus 56. And to get y completely by itself, I'm going to divide both sides by 7. and that gives us a negative 4/7 x plus 8. Now we are in slope-intercept form. Well, we also could be given a point in the slope. Well, if we're given a point in the slope, we're going to use our point-slope form and then solve it for y so it's in the correct format. So, remember your point-slope form, y minus y1 equals m times x minus x1. We're going to plug in our point for x1, y1. And our slope is a -6. Now we solve for y to get it in points or to get it in slope-intercept form. Going to distribute that -6, and I'm going to add the 3 over to get y completely by itself. And now we are in slope-intercept form once again. We also could be given 2 points. Well, if we have 2 points, we don't quite have the slope yet, but we do have a point. So again, we're going to be going that route using our point-slope form. But first we can find the slope. To find the slope given 2 points, we're going to use our slope formula. And we're going to plug in 1 point. I'm going to call this second one 0.2, this first one 0.1. We know it's y2 minus y1 over x2 minus x1. 4 minus 1 gives us 3 on the bottom. 4 minus a -3, well, that's the same thing as -4 plus 3, which gives us -1. So our slope is -3. Now that we have the slope and we have multiple points to use, we can plug it into point-slope form once again. I'm going to use this point. Y minus my y-coordinate equals my slope times x minus my x-coordinate. Well, I'm going to distribute my -3. This is the same thing as x plus 3 on the inside. And so I have -3x minus 9. I add the 1 over. And so the equation of this line is -3x minus 8. Again, solve for y so it's in slope-intercept form. Finally, we could be given a point and then we're given some equation that might be parallel, it might be perpendicular. Well, remember, if it's parallel, the slopes would be exactly the same, but since this one is perpendicular to this line, we know our slope is going to be the opposite reciprocal of that. Well, the opposite reciprocal of 3 over 2 is a -2 over 3. And so now we have our slope. Our slope is that -2 over 3, and we have a point. So again, I'm going to use point-slope form. Y minus my y-coordinate equals my slope times x minus my x-coordinate. And again, I'm going to solve for y. Distribute that -2/3, gives me a -2/3 x plus 2, and I'm going to add 3 to both sides to get y equals a -2/3 x plus 5. Well, again, finding slope-intercept form for the equation of a line. This time we are given the graph for that line. So all we need to do is determine what our y-intercept is. It is 2, and we need to determine the slope. Well, as I pick 2 points on the line, I can count that it goes down 3 and over 1 to get to that next point. So our y-intercept was 2, the slope was down 3 over 1, which is a -3, and we just plug these things in. This is going to be y equals -3x plus 2. Right. So we want to evaluate. We've got this expression right here. We're told that x is 3, y is 2. So I'm going to plug in a 3 for x, exactly where it is, and a 2 everywhere I see y. So I have a 2 squared plus 2, and everywhere I just plugged in a value. I made sure I put it in parentheses. So on the outside I have a 3, but I want to do my exponents first. 2 squared is 4. Now I'm going to go inside my parentheses. 4 plus 2 gives me 6. And of course, 3 times 6 comes out to be 18. So we just plug in the values we evaluate. Over here, we're given a circle, and we want to find both the circumference and the area, knowing that the radius is 7 feet. And we're told to use 3.14 for pi and round to the nearest tenth. Well, our circumference is pi times the diameter, and our area is pi times radius squared. So if we find our circumference first, the circumference is pi times the diameter. Well, if the radius is 7 feet, the diameter is going to be 14 feet. So simply the circumference is pi, which we're told to use 3.14 for pi, times the diameter, which is 14. Well, 3.14 times 14 comes out to give us 43.96. And since we want to round to the nearest tenth, well, because of that 6, that 9 is going to go up. So this would be 44.0 feet, because the circumference is the distance around. We're talking about it being in feet. Well, the area, pi r squared, our radius is 7, so the area is going to be pi times our radius 7 squared. So this is 3.14 times 49, and 3.14 times 49 comes out to give us 153.86. Once again, this 6 is going to round the 8 up. So to the nearest tenth, this is 153.9. And because we are talking about area, this is not just feet, but this is feet squared. So there's our area, and there's our circumference of the circle. Well, if we're looking at a triangle or any kind of shape, we want to be able to find the area of it. The area of a triangle is 1/2 base times height. Here's the base, here's the height. It's all labeled for us, nice. So we want to do 1/2 our base times our height, 5.4. And we know we just multiply all this stuff together. 1/2 times 7 times 5.4 gives us 18.9. Because we're finding the area, we're not just in kilometers, but we're in kilometers squared. Finally, if we want to find our missing measurement, well, we can use our formula. Plug in what we know. Well, to find the area of a rectangle, it's base times height. So I know I'm missing this height right here. And my base is 8 centimeters. My area, I know, is 56. Well, to find the height, I just solve for it. And so my height comes out to be 7 centimeters. All right. That's a little review going into geometry.